All right, class. Let us look at this a short topic on soaps and detergents. Uh, this is one of the uh, topics which you've dealt with in one or another one. You cannot say you've not seen or you've not touched soap, you've not touched a detergent. Um, Now, now this small topic is just going to uh, just give some small chemistry uh, on the chemical structure of soap and also for detergent. What you're going to see is that, and I think it's something which you've realized uh, that soaps uh, cannot be effectively used in hard water. It means that the by hard water it means the water with the with the ions uh, like what like calcium, magnesium, and an ion such as sulfate, carbonate, and the rest. Yeah, that if you're just going to use soap, you're going to see that you'll be getting something like a scum or something. Uh, so you're just going to use the soap will just be getting small, but it will not be removing the dirt or 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 really working in a way. So in this case, you're going to see that the presence of the hard water is just going to replace the anion which is soluble in the soap with the insoluble one which is found in the hard water, and you're going to get a precipitate out of it. So let's say that that the soap is made up of treating fats and oils with alkali. So the difference between fats and oils is actually the melting point. What you're saying, going to say that a fat is going to be a solid at room temperature, as opposed to an oil which will be a liquid. Yeah, and you're going to see that you can start up with an oil like what you're going to say is that fats are made up of oil such as palm oil, yeah, which is available in nature. Probably in Kenya it's not produced, but there are countries like in West Africa or even in Malaysia, in the yeah, in some of the Asian countries, they produce a lot of palm oil. So through a process of hydrogenation, you can be able to add some extra hydrogens onto the many double bonds that are available in the oils, and try to increase the molecular weight, and try to change the the oil into a fat. Yeah, yeah. So uh, so oils are liquid at room temperature, as opposed to fats are solid. Yeah, they're just made from the same structure. Uh, it means that uh, you start off with an oil, and by trying to add hydrogens, you are going to convert the oil to the fat. Now, now in nature there are complicated. Okay, I think before then, this is something which we've not dealt with, but I think I would like to mention one of the simple reactions that you're going to be dealing with. If you're going to have a carboxylic acid, you can be able to react it with an alcohol to form a derivative of a carboxylic acid called an ester. Yeah, please. I hope you'll be able to, in case your name is ester, you're going to distinguish between the chemical ester and the lady's name, which is are you seeing the difference? Or maybe I may use a better pen. Okay. So So for the lady's name, there's an extra H, yeah. So you'll be able to distinguish between the ester, which is a name for females, as opposed to the ester, which is a compound which is made a derivative of a carboxylic acid. Yeah? And once again, I put an equilibrium arrow. What it means is that I can have an ester and I've got an alkaline, which is what happens in nature or which is happening in the industry, to which an ester plus an alcohol, I mean plus salt of a plus an alkaline, you're going to form an alcohol plus carboxylic acid. But a carboxylic acid, because this alkaline has got a pH of more than 7, is going to react with your acid to form a salt. Yeah, an acid plus a base is going to form a salt and water. So that alkali, like sodium hydroxide, is going to react with your carboxylic acid to form a salt of carboxylic acid. In this case, it's going to be sodium carboxylate, plus water. So that sodium carboxylate, if it's made up of the from the fats and the oils which are available in nature, that salt is the one which you're going to be calling soap. So soap is actually a sodium salt of a long chain carboxylic acid. Scientists have also been able to produce a potassium salt. So you can have a potassium or a sodium salt of a long chain carboxylic acid, which I'm going to be calling soap. And as I mentioned here, soap is not soluble in hard water. So scientists, they found a way of how to use to make a cleansing product which is soluble in hard water, and in this case, they had to change the structure from a sodium salt of a carboxylic acid, which is soap, to a sodium salt of sulfonic acid. Sulfonic acid is related to sulfuric acid. For sulfuric acid, the R is replaced with the OH, yeah? So that in this case, a sulfuric acid, like in this short structure, can be RSO3H, yeah? RSOO3H, yeah? That's a sulfuric acid. But sulfuric acid is H2SO4. So it means that for sulfuric acid, the R is changed with the OH, yeah? So sulfonic acid and sulfuric acid are related. So you are going to have sulfonic acid, it reacts with the sodium salt of, it reacts with sodium hydroxide to form a sodium salt of sulfuric acid, which you're going to be calling the detergent. And detergent is going to be soluble in hard water. So it's not going to precipitate out in the presence of the ions such as calcium, magnesium, iron, and carbonate, and sulfate, and the rest. Yeah, so it's going to be soluble in that. Now, in the notes, you are going to, in the soft copy of the notes, there's some things which I've added on that one for you who may be interested in trying to make some industrial products. One is that I've put forward a procedure in the notes on how, exact procedure, which it means that you can be able to carry out on how you can use vegetable oil to make soap. Yeah, the exact condition, including the quantities and the temperature and everything. Yeah, how to really make. So there's a procedure in the notes on how to make soap using vegetable oil, and something which you can actually do that. Another thing which I've also put in the notes is I cannot just say you've got a sulfonic acid and then you put an alkali and then you're going to get a detergent. If you want to compete with probably Omo and maybe Ariel or Parcel with other detergents, you've got to add some compounds to it. And in the notes, you're going to see that that things that you need to add to be able to add value to your detergent. It means the detergent, this is the basic structure, but you're going to add some things. For example, uh, you may want your detergent to be able to, uh, in addition to just the washing, you may want it to have some bleaching agent. For example, uh, if you just want to be dealing with making white like this one, which has got a stain to make it white, then you're going to add sodium uh, hypochlorite. Yeah. Uh, but if you do not want to, but if it's not white, then you're going to use a peroxide uh, as your bleaching agent. Bleaching agent you use, if it is colors, then you're going to use a peroxide. Excuse me. So you can add bleach. There's some optical brightness, like it's called blue, uh, which you can be able to make your white really shine in white light. Um, that one can be added in a detergent. Um, Now this third one which I put there is quite important, and I think for all of you who've done washing, you know that that sometimes if you've got something like blood stains or some stubborn stains, you are much better uh, not washing immediately, but doing something called soaking. So this soaking makes use of the enzymes that are added in the detergent to try to break down some very stubborn covalent bonds. Like in this case, there can be proteins. So the enzymes which are available in the detergent are going to break down. What? Some of those bonds before they cannot be removed by the detergent. Colors, different colors, perfumes, and the rest. So in the notes, excuse me, you're going to see some ingredients that can be added onto the detergent case in case you may wish uh, to in addition to being an engineer, you may want to become a chemist and try to make some of these products. It's good to survive, yeah, to be able to make a detergent, and it can sell. Who knows? Yeah. So in the notes you'll see um, about the degradability of the detergent, and other topics that you're going to see there. So soaps and detergents are very critical products uh, that you'll encounter almost every day in your life. Yeah. So I think that's the much I'll talk about soaps and detergents. You'll be able to look at the notes, and also uh, information that you can get from the internet regarding some of the uh, uh, ways in which you can make uh, uh, soaps and detergents in a commercial manner. For example, you're going to see, if I may mention, uh, if you're just going to make soap using the procedure that you're going to say, like in the next, you're going to see you may make use of an equipment that you will need to press to be able to remove some of the water. Otherwise, your soap may be what? Uh, may be too soft, and it may break down in water and the rest. So there is an equipment that you may need to try to make your soap really hard, but not very hard. So you're going to see that if you're going to make your soap from something like some of the fats, you may need to add something like a coconut oil and the rest. Try to make it not really very hard. There are those industrial secrets on how you can be able to make a soap which can appeal to certain customers. So I think for now, I think that's as much I talk about soaps and detergents. And I hope you really enjoyed. this short topic. Yeah. All right. Thank you very much.